So to continue where we left off with regard to this emergent property of water to have high specific heat, what this does is allows water to absorb the heat from the sun and to change for the sun to go down and the sun to rise, etc., without its body actually changing substantially. You might have some changes in water temperature in certain areas, but what you have is generally the whole body of the water, it remains a fairly constant temperature. And that's important with regard to sustaining life. Life that lives in the water needs to have consistency in temperature, consistency in chemical makeup of the water, because if we have any changes, then we have something that particular life form hasn't evolved for, and that then becomes a problem for when we talked about evolution, etc. So this idea that temperature has this ability to stabilize, that water has the ability to stabilize temperatures, is the next emergent property that's conducive to allowing life. And what you have in this image is the fact that the temperatures inland, like San Bernardino or the desert, can be up to 100 degrees, but what you have along the coast, because water is absorbing the temperature or absorbing the heat from the atmosphere, you have cooler temperatures along the coast. And also water has, again, you have a constant flux with regard to absorbing the heat and creating these hydrogen bonds and then releasing the heat by breaking the hydrogen bonds. Next emergent property is the fact that water is less dense when it's in solid form than liquid form. And this again is because of the hydrogen bonds. What happens, and we can see this, ice floats in water. It's less dense. And we have this concept that the bonds become more ordered in ice. So remember, or we said that temperature or heat is measured in kinetic energy. And I don't know about you, but the colder I get, the less I move. Actually, the more you're supposed to move just to warm yourself up. But what happens in terms of water, the colder the temperature, the ambient temperature, the slower those hydrogen molecules or slower the compound molecules actually move. And what happens is eventually it gets to the point where these hydrogen bonds that are constantly being made and broken kind of decide, okay, we're good right here. This is about arm's length away from each other, so we're all just going to stay right where we are, and we still have our hydrogen bonds, but we don't have our hydrogen bonds. That's what they mean by ordered. And that's also what they mean by freezing. Water freezes into a crystalline form because the kinetic energy is reduced, and these hydrogen bonds then organize into a space that actually takes less space than if they're moving around a whole lot. And the other thing about ice is we need it to float, because if it sank, it would cause all the bodies of water to freeze. And the other thing that happens is, since ice floats and it's on the top of the water, and you have a little microclimate happening where heat is absorbed and lost via this ice, you have the ability for for life to take place underneath it. And that's why you have this middle picture where you have this little aquatic species that is living underneath the ice and is able to live under the ice because ice is an insulator. It actually allows for the water underneath to not have such dramatic temperature fluctuations. Then water is a solvent, another property. As a matter of fact, we call it the universal solvent. And the definition of a solvent is the ability to disassociate or to break apart bonds, particularly ionic bonding. When you have water, which is the solvent, and then something in it that is going to break apart in terms of ionic bondings, you have a solution. It's a liquid that has, so you can think of water with salt in it, melted or dissolved in it. The solute, which would be the salt in this case, is a substance that's dissolved. So you put the solute into the solvent and you have a solution. I didn't create these words. I think they should have created words that had different first letters, but the solute is the item that's being put into the solvent. In this case, we're talking about water, and the two together is called the solution. An aqueous solution is one that specifically is using water as the solvent. Generally, if you're speaking trying to speak very correctly, you'll call it an aqueous solution. Water is a very versatile solvent because of its polarity, which allows the hydrogen bonds to form easily. Remember, hydrogen has kind of the polarity to it. With regard to particularly sodium chloride, you're going to have a polarity to those ions. That polarity, the polarity of those ions, the positive and negative charge of those ions, is going to be attracted to the polarity of the water molecule. Again, positive and negative charges they're attracted to a certain degree to other compounds. In this case, the cations and anions of sodium chloride are attracted to the polar aspects of water molecules, so it actually causes them to disassociate. Water can also dissolve compounds that are made of non-ionic polar molecules. It's just not as dramatic, I guess I might say. And what happens with ionic compounds that are dissolved in water, they get surrounded by a hydrogen shell. So they get surrounded by hydrogens. That surrounding by hydrogen walls them off, so they're not able to get back together with each other again. So they stay in solution. They're kind of put in little compartments because of the hydrogens. In terms of substances that we have in the body or substances that exist, some substances have an affinity for water. We call those hydrophilic. Have an affinity for water, and some substances don't like water very much. So you can think of hydrophilic substance, something that dissolves pretty well in water or disassociates in water. The one that comes to mind with regard to hydrophobic are oils. You can just think of oils actually floating on top of water as opposed to actually submersion into water, like sodium chloride again. But oil molecules are hydrophobic. The image that you have down here at the bottom, the hydrophilic, you actually see how the liquid will submerge into the water, whereas hydrophobic, just like an oil molecule, will sit almost like on top of the water. Colloid is defined as a suspension of fine particles in a liquid, and generally it's a stable suspension, meaning you have water and you pour a substance in and you stir it, then the substances are held because of this hydrogen bonding in a very regular pattern away from each other in suspension. The concentration can be measured with regard to a aqueous solution, and we can measure that concentration of solutes by moles per liter or moles per amount of liquid. But what happens is the higher the concentration, the more likely you're going to have collision of molecules making kinetic energy, and you're going to have more likely to have chemical reactions the more solutes you have in that solution. So the more concentrated the aqueous solution, more likely you're going to have biochemical reactions. The next concept is about this pH, or the which is the scale. But before we talk about this, talking about acidic or basic. Remember again, water is oxygen and hydrogen, and the acidity of a particular solution is measured by the number of hydrogen ions. So the hydrogen atom in a hydrogen bond between two water molecules can shift from one to the other. So can actually move. Doesn't happen that particularly often with regard to water, but can move, can shift from one oxygen atom, one oxygen element to another. And then leave behind, if the electron is just shifting, you have a hydrogen ion, which is a positively charged, because remember that that electron is probably staying around the oxygen. You have a positively charged, and then you have a positive charged hydrogen ion. That is our measurement of acidity. And then the thing that's left, remember H2O, if we take a hydrogen ion off, leave the electron behind, we have now have a hydronium ion. And the molecule lost, actually the molecule with the extra protons, now hydronium ion. The one that's left is the hydroxide ion, which is OH negative. That is our measure of basic. So this diamonism between the water molecule, where hydrogen ions are taken off, and you have the proton without its electron, so it has a positive charge, and then you have the oxygen and the hydrogen that's left with the extra electron, so you have a hydroxy ion with a negative charge. You have this happening not very frequently because water is in the dynamic state of equilibrium. This means that this dissociation is happening about the same time that they are reforming, which actually keeps water at almost a pH neutral. The changes in hydrogen or hydroxy ions, so positive and negative ions, can dramatically affect the chemistry of the cell. Again, most things are adapted or evolved for a specific pH, for a specific amount of level of hydrogen ions, level of hydroxy ions, and if you shift this, it can cause extreme problems for that living thing. Think about, you might have heard about these toxic blooms. And the toxic blooms are the ability for certain organisms to be more productive than others because of a shift of pH. And we will move on to the next teaching time.